So in the previous section, we have seen uh, tensor data type and the tensor particular functions. Like we had metrics. First we had scalar, then we had vector, then we had matrix, and now we have tensor. All right. So we were working upon all these values. So now we will see, like, suppose float underscore 32 underscore tensor. It is the data type name, and I'm going to create the torch dot tensor, and along with the round bracket I'm going to create one 3.0, let's say 6.5 and 8.2. All right. And also d type, I'm going to define the d type nothing. So I'm going to create d type nothing. So default to none, which is torch float 32 or whatever, it will create that kind of. And also I'm going to define device is equal to none. So you can have device, like by default it uses the default tensor type, device type CPU, or you can change in CUDA or another type also. Let's say another parameters, it requires grade. What is the grade value here? So if it is true, then operation perform on the tensor, and it is having different section like tensor or R recording. So as far as device is concerned, which uses the default tensor type, and we will have the particular uh, device over there. So I'm going to run that. So it's going to tensor. Okay. So first I'll have to import that tensor value. So I didn't import torch first. So hit enter, run this code, and again running this my float 32 tensor. So now you can see there is no error, and I'm going to print that value and then enter the required value. So you can see it's having float tensor 3, and the value requires grade is equal to true. And suppose I'm going to hit enter, you can see it's giving the requires grade is equal to true. So aside from shape issues, two of the commons are PyTorch data types and device names. You can have one of tensor is float 32, and another data type we have float 16. So so often means PyTorch use often to be same format, and one of our U tensor is on the CPU and is another is on GPU. Then you can have the particular data type, right? So using the same code, like suppose I'm going to copy this code, C here, and cut V here, and now I'm going to create D type. All right. So what will happen if I'll type D type? All right. So you can see it's a float 32, and now I'm going to change D type, data type of this particular tensor. So I'm going to change, okay, X and cut D, and I'm going to change the data type. So that's now torch dot float 16. So previously it was float 32. So now I have changed the data type and going to print that data type. You can see now it's a torch float 16 of kind of, right? So this is all about getting information from tensors. Once you have created tensors, you might want to get some information like shape, data type, device, what data types are elements with the tensor stored, what shape is there, what is the data type, is it means device type, is it usually GPU or CPU. Okay, so suppose I'm going to create tensor aim and have like torch dot rend and some 3,4 values. I'm going to copy, going to run that tensor aim. So you can see 3 rows, 4 column randomly assigned. So if you want me to run this code again, I'm going to run this code again, and you can see the values are changed now because it's not constant here. It's some simply different values. All right. So if I were to print tensor underscore aim, so I can print there. If I want to print the shape of the tensor, so how will I would print f and then quotes, double quotes, and I'll write my statement shape of tensor, and then I'll write the curly bracket. Inside this I'll write my variable tensor underscore name dot shape. All right. Similarly, I'll copy this code, courtesy, and hit enter, cut V. And now I want to print the data type of my tensor. So I'll use data type of tensor, and I'll use tensor aim, my tensor name, variable name, and then the type. All right, close by this round bracket. Similarly, I'll use the same skeleton and use in order to get the device of tensor location where it is stored. Right, so for that I'm having my tensor variable name dot device, what is kind of operating system is there, right, and hit enter. You can see it's a shape is 3,4. all right, and second is data type of tensor is float 32. By default it's taking 32. Device of tensor location is CPU. So most of the time my PyTorch is taking CPU. You can convert into like TPU, tensor processing unit, or GPU as per your need, right, as per your machine learning or database requirement and the performance. So now we were going to moving towards manipulating tensors. All right, so manipulating tensors, there are various ways. Like first we are having adding, right, then we will see subtraction, multiplication, division, and matrix multiplication. All right, so suppose I'm having tensor under tensor is my variable name, and then I'm use torch dot tensor, and then square bracket, then 10, 15, let's say any random values there, and then I'm going to create tensor plus 10. All right, hit enter, and you can see it's just increased by 10 integer element wise increment performed there. So 10 plus 10 20, 15 plus 10 25, 18 plus 10, that is 28. Now I can have tensor multiplication 10. You can see it's each element is multiplied by 10 now, right? So this is multiply it by 10. All right, so how the tensor values above didn't end up by tensor, and this is because the value inside the tensor don't change unless they are reassigned. Right, so if I'm going to print tensor, you can see it's original, it's showing original value 10, 15, 18, not the converted value. Okay, so how to change the, how to get the impact of this? So nothing, you just do nothing, you just assign tensor is equal to tensor multiplication 10. All right, and I'll print this tensor again. You can see now my original values are changed to 100, 150 and 80. So this is how you can create and you can means change your value. All right, but we have another like another shortcut, like how to do that another function. So we have so many other functions like tensor dot multiply mult torch dot mult I ply multiply, and then I use tensor comma 10. All right, so now I'm going to use tensor. You can see it's having 100. Okay, so it's going to multiply this original value, and but I'm going to use this tensor. It's showing again original value. So how to impact that? So it's going to impact that so element wise impact. All right, so it's going to perform. Okay, so what should I do? I'll have to assign sorry, tensor is equal to tensor dot multiply tensor comma 10, and then print tensor. You can see now it's changed with revised value 1000, 1500 and 1800. All right, similarly if you want to let's say means element wise perform element wise multiplication. All right, so how to do that? So we will use print, directly use print and tensor asterisk tensor. So that will use the tensor and element wise multiplication. You can see it's not matrix multiplication but element wise multiplication. All right, so as of now what we have seen adding, and we have seen here multiplication. All right, or means you can, instead of adding some value, let's see, let's say I'm having different value 2 comma 5 comma 7. I'm having 10 minus 10, and you can see it's going to subtract that value also, subtraction. All right, okay, so if you want me to divide with something, you can do that. Okay, so I'm going to divide that value. So tensor is equal to tensor and divide some value, right? So I'm going to print that tensor again. It's showing the original value because I have not defined the tensor with the revised value. So tensor, and going to run that again. You can see all the elements are divided by 10. So 10 divided by 10, 1.00, 15.10 divided by 10 is 1.5, 18 divided by 10, that is 10, that is 1.800, and so on. So this is how we have done multiplication, division, and elements wise multiplication, and so on. All right, so one of the most common operation in the machine learning and deep learning algorithms is matrix multiplication. You can see everywhere matrix multiplication. All right, so inner multiplication dimensions, like you must have the outer dimensions and the different values. All right, so what will happen? So the main means PyTorch implements matrix multiplication by using like torch, that we have function torch met mul round bracket. So met stand for matrix, mul stand for multiplication, right? So the main two rules for multiplication, you remember that inner must match, right? So if you are having like any value, like asterisk any value, so the dimension of the first matrix is like 5 comma 7, and second is 7 comma 5. So obviously it don't work. All right, so it will not work, right? So second parameters, let's say 1 comma 4, and then 4 comma 5, right? So obviously it will work because it's matching the inner dimensions. All right, so inner parameters are changed, so that's why we are having the basic multiplication rule. So you must have the resulting matrix output and all. So it will give the output of the dimension 1 comma 5, obviously. All right, so now we are going to implement that function as well. So we have one more function, tensor. It's a variable, tensor dot torch. Tensor is equal to torch dot tensor, and then square bracket 1 comma 2 comma 3, and then tensor dot shape. Right, I'm going to hit that, the tensor dot size, and we are having it's a size 3, right? So similarly, if we want to perform like torch dot met multiplication and give the input of the tensor and hit enter, one parameter tensor. Okay, so tensor multiplication, not stick is not required, comma is there, so it's having 14. Okay, so we can have like tensor multiplication, that value, and I'm going to print tensor mul, right? Okay, so tensor dot, okay, so we can also use for matrix multiplication. Okay, so we can have more values there and more. Okay, so instead of so you can see 14 value is there. So 1 2 3 1 1 plus. So how we are obtaining 1 means 14 there. So it's just because like 1 asterisk 1 plus 2 asterisk 2 plus 3 asterisk 3 equal to 1 plus 2 to the 4 plus this is a 9 plus that is equal to 14. So this is why we are obtaining 14 here. That is the matrix multiplication and the part of the given value. Okay, so instead of the entire value, like entire function statement over here, we are having shortcut. So what's the shortcut for there? So we can have at the rate there. So tensor at the rate tensor, right? So once I'll print tensor, it will give tensor multiplication underscore mul, that is 14. All right, so it's giving the particular value. Okay, so we can do matrix multiplication by hand. It's not recommended. You can have for loop, and you can have the particular element and loop at all cost. They are computational, very expensive, right? So if you want to check the time value for this matrix multiplication, so tensor and hit run, you can see the CPU time is total 0 second, and CPU multiplication it's I have already done here, so that's why it's not giving any value. Suppose I'm giving any new value there and just hit enter, and let's say I'm having 100, here I'm having 21, 34, let's say, and I'm going to print over there. Okay, so it's not giving as of now because it's very low value. And then if you will have large calculation, so from there you can have the percentage time in order to calculate that value. All right. All right, so similarly we can have the matrix multiplication of different values and matrix value for the different aspect. Right, so we have, okay, so we can, instead of multiplication, we can have also, right? Because it's a, most of the times self matrix must be a matrix, right? So there is a self matrix, and you can have the this one, and you can print over there, right? You can print for the element wise elements, not the particular value. All right, so this is the dot product you can have. This is the another function you can have along wise, and you can perform more elements and more values. All right, so as of now we have completed this module. Like you can use matrix MAT MUL, and then remove that L, and tensor comma tensor, and hit run. You can see you will find the, okay, cut C, I'll find cut V, and I print that value on the screen and just hit run. You can see now it's going to print something, and have you CPU times total 15.6 millisecond and volt time 1.97. So volt time is what it is. It is just nothing, right? So volt time. So we are going to search that volt time. Volt time in Python. Right, so for volt time you can use time default, which gets the timer within best granularity describable. For that you can give the, right, so what is volt time in Python? So elapsed real time volt clock time. It's a volt clock time. Volt time, or volt time, is the actual time taken from the start of a computer program to the end. In other words, it's the difference between the time at which task finishes and the time at which task started. Right, it's a difference between them. And CPU time is different, like, all right. So CPU time of the current process, we can calculate the float and integer both values in seconds and then in seconds, and you can have the process, how much time is taken from the process, and so on. Okay, that's it for now. We'll see in the next class. Thank you.